Welcome back to the Niagara 4 Learning channel. So we're working again with these compact I/O modules, and I've already added them to my sheet Modbus 2 on my N4 wire sheet. So we're going to go and check some of these points out. So the digital input 16. So the digital inputs, these are the Modbus addresses. So it's all Modbus address, all the same Modbus address, but when you go into one of them, you will see that that bit number is 0, holding, Modbus holding bit number 0, bit number 1, bit number 2, and so on. So we don't need to go through them all. The pulse width settings for the digital input 16. So minimum pulse width DI1 is using Modbus address 4007. Beginning 0, number of bits 8. Beginning 8, number of bits 8. So that's your 16 bits for your 4007. You can see 0 and 8 for that one, and 8 and 8 for that one. Pulse counts, different registers there. 40015, we'll look into one. Holding, integer. Pulse speeds, again they're all different Modbus addresses. Holding, integer, and that's just the version. So that's the DI16. So now let's look at the DO16, the digital outputs. So they're my outputs. Again, they're all the same Modbus address. That's bit number 0, bit number 1, bit number 2, and so on. Let's just rearrange them. Reorder. Put that up there, and put that up there. Default values. So that's true. 40020, 40021. So the reason for that is if we lose communication, that one, digital output 1, will be true. If we do lose the Modbus communication, it will put that output to true. Normally you'll just have them all to false, but in case of some equipment that you want to be on constantly, when you've lost your controller or the network to your I/O modules, you can set these to different values. And then default value enables. So I can put that to on if I wanted to. So 4002, and that's bit number 8, 9, 15, right at the bottom there. So analog inputs. Input raw values. Now I've got connected, I think, yeah, I've got a temperature sensor connected there on that analog input, and then nothing connected to the others, but let's have a quick look. 4001 integer, holding 4002 integer, and then sensor values. So that's my temperature sensor in there at the moment, and nothing in the others. 40024. Sensor type settings. So I've got a 1 for that. So that's the 10K. Let me find you the data sheet for that. Bear with me one moment. Right, this has been from BMS parts. You can see here that 0 equals ohms, 1 equals NTC 10K, 2 equals PT 1000, 3 equals NTC 20K, 4 is NI 1000, and 5 is also NI 1000, but DIN at the end. Okay, I presume what we could do is we could make that easier, and instead of having, if I just move that across to that side out of the way, and where I've got my sensor types, if I do a new and I do an enum bits writable and take Modbus address 40015, go OK, and then go into there. I don't want that. Let's just take that one. I'll do it here, and I can just copy it across. So 0 equals ohms, add. 1 equals NTC 10K, 2 equals PT 1000, 3 equals NTC 20K, 4 is NI 1000, LG, and 5 is NI 1000. Then go OK, 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 click that, OK. So that's stale because of the 415 already there. So if I delete that 4015, Modbus 40015, OK. Just rename that, Control key C, rename, Control key V, AO1, sensor type. So now all we need to do to set the sensor is actions, set, and you can select which one you want. So if I go ohms for that one, okay, that's now selected to ohms. So if I look at the sensor value, that's now changed it to ohms. Actions set to 10K. Sensor values, that's now back to temperature again. And I presume what we can do here is we can add on the temperature. So you got the degrees C there. And I presume what we can do with this now is I can just duplicate that. And that's going to be 2. I need to just put something in there for the moment because that's going to go. So that's integer. So let's delete that 16. Modbus 40016. Okay. Rename that. take out that. Reorder. Action, set that to default ohms. Look at the sensor values. That's simple enough, isn't it? That's probably better to do it that way. So I could do the same with 3 and 4. Let me just pause you and I'll just do the others. Okay, so now we have it. We have all of them there that can be adjustable. 15, 16, 17, 18, 19, 20, 21, 22 Modbus addresses. So you don't need to guess on the data sheet now, which is here, these here, what you are actually using. So that's that one done. And I got the data sheet from here, these PDFs. You can download these are Modbus registers from the website. Right, so now let's look at the next set, input enables. AI1, so that's bit 0, that's going to be bit 1, and so on through to bit 7. And then analog outputs is the next one that we need to look at. So 0 to 10 volts, integer, you can adjust the scale there, and default values. Modbus 40010, 11, 12, 13 and through to 17. So you've got default values on those points as well. I think that's it for the I/O. So we've got 16, 32 and 2 8s there as well. And quite a lot of I/O in a small space, as you can see from the picture. The D16, D0016, AI8 and the A08. It's quite a small footprint compared to an I/O of the same type, i.e. value, like 16 and a 16 and an 8 and 8, that would be quite large. Anyway, that's it for this video. If you like it, can you please put like and subscribe? Thank you very much for watching.